So here's a quick table to help you remember how to create the exact values of sine and cosine really quick and easy. But one detail I want to point out. Notice when I create this table, sine is first and cosine is second because it just makes the table easier to build. I want you to always remember an ordered pair, the x coordinate is cosine, the y coordinate is sine. So the only reason the table is in this order is to make the pattern really easy to follow. So all we have to do is we start with 1, then 2, then 3. So we're counting up. Then we go backwards with 3, then 2, then 1. Now, the next step is these are all fraction bars. So 2 is going to be our denominator for every single fraction. So once we have all our fractions over 2, the very last step is to take the square root of the numerator. So notice the square root of 1 is just 1. So this 1/2 stays. This 1/2 down here stays. But up here, the 3's and the 2's, we have to put under a radical. Now, in the past, I have shown you how we actually calculate these values. This is just a quick trick to create a table to go through and get the sine and cosine of 30, 45, and 60 degrees so that you always have them. The last thing is tangent. Now, if you remember, tangent is really sine over cosine because if you think about SOHCAHTOA, it's opposite over adjacent. So the sine theta is the side opposite. The cosine theta is the side adjacent. So tangent is really sine over cosine. So for these values, all we have to do is actually divide sine by cosine. So for the first one, we get 1/2 divided by radical 3 over 2. So we take our sine of 1/2, we divide by our cosine, radical 3 over 2. And remember, division is really multiplication by the reciprocal. So we have 1/2 times 2 over radical 3. The 2's cancel, and they leave us with 1 over radical 3. But remember from our work from today, we're rationalizing the denominator. So we don't want radical in the denominator. So we're going to multiply 1 over radical 3 by radical 3 over radical 3. And please note, all I'm doing is multiplying by 1, but I'm multiplying by a version of 1 that helps me get rid of the square root of 3 in the denominator. So in the denominator, I have radical 3 times radical 3, which gives me the square root of 9, which is just 3. In the numerator, I have 1 times radical 3, which gives me the square root of 3. So the tangent of 30 degrees is radical 3 over 3. And if you know the sine and the cosine, you can always use those values to find tangent. So I'm going to put all this stuff off to the side and just put my answer for tangent in the box. Now, when we go to cosine, when we go to 45 degrees, the sine of 45 is radical 2 over 2. The cosine is radical 2 over 2. So even though those are ugly fractions, they're exactly the same. So when I want the tan of 45 degrees, it's this over the same thing. Therefore, the tangent is 1. So again, those 45s give us a really nice tangent, which is awesome. So now when we look at the tangent of 60, it's radical 3 over 2 divided by 1 half. So radical 3 over 2, divide 1 half. We keep our radical 3 over 2, but we take the reciprocal of 1 half and we make it 2 over 1. So the nice thing here is we don't have to rationalize the denominator. The 2's cancel. Radical 3 over 1 is just the square root of 3. Since the square root of 3 is in the numerator, I'm done. So the tan of 30 degrees is radical 3 over 3. The tan of 45 degrees is 1. And finally, the tan of 60 degrees is just radical 3. And that's a good table to help you. If you can figure out the first quadrant, you can use all these values to kind of find your symmetry for quadrants 2, 3, and 4, whether you're in radians or degrees.